Hello everyone. Today we will see how to balance a redox reaction. Okay. So in balancing a redox reaction, you have to study only two methods. One is by oxidation number method. The first one is oxidation number method and the second is half reaction method. So two methods you have to study for balancing the redox reaction. One is oxidation number method and second is half reaction method. Okay, so first we will see the oxidation number method. So there are certain steps or rules to be followed while balancing the redox reaction by oxidation number method as well as the half reaction method. Okay, so the first is in whatever reaction we are writing to balance it. Now there you have to get the correct formula for the reactants and products, isn't it? For that matter, it is any reaction. For that matter, any reaction. To balance a chemical reaction, you have to know the chemical formula, the correct formula. For example, if you want to write sodium sulfate, and if you don't know the correct formula, someone would write NaSO4. Is it correct? No, it is Na2SO4. Then the whole thing gets wrong. So that is why it is very necessary to write the correct formula for each reactant and product. That is the first step. Then the second step is you identify the number of atoms which undergo oxidation and reduction. Correct. By giving oxidation number to all the elements. We will see. We will take one example and see how to balance the redox reaction using these rules or steps. So you have to identify the atoms which undergoes oxidation and reduction. And again I am telling you, oxidation means there is an increase in oxidation number, whereas reduction means there is a decrease in oxidation number. Correct. So once you identify the atoms which undergo oxidation and reduction, then you calculate how much increase or decrease is there in the oxidation number per atom and for the entire molecule. Correct. So you have to calculate how or what is the increase in the oxidation number. Is it from, for example, if it is +6 to +8, there is an increase. Then decrease. So if how much is the increase? +6 to +8 +2. Now what is decrease? If it is +8 to +6, then there is a -2 decrease. Correct. So you have to calculate the increase and decrease in the oxidation number per atom and for the entire molecule. Correct. Okay. Now if they are not equal, make them equal. So that we will see in each step to cross multiply that. Then the fourth rule is ascertain the involvement of ions if the reaction is taking place in water. Now if you say the reaction is taking place in an acidic medium, then what happens? Add H plus ions or OH minus ions on the appropriate side. That is sometimes it will be in the reactant side or sometimes it will be in the product side. So you have to add this H plus ions and the OH minus ions on the appropriate side so that the total charges are equal. So while doing an example, you will know how to go for it. And the last is make the numbers of hydrogen atom equal by adding water molecules. And then the last one is check the number of oxygen atom. So if they are same, then you can say it is a balanced equation. So these are the simple rules you have to follow while balancing a redox reaction. Okay. Now what we will do? We will do one example. Okay, we will do one numerical for this so that you can get a complete idea of how to use the steps. Correct. Okay. That is, see, this is the question. Listen. The question is, here you have to, they are asking you for writing the ionic equation. See, so write the net ionic equation, that is ionics, you have to write it in ions, in terms of ions, for the reaction of potassium dichromate and the sodium sulfite, SO3. In acidic medium, see, in acidic medium, so there must be H plus. From this you will get a hint from the questions to give Cr3 plus ion and SO4 2 minus ion. Okay, so you have to, if the question is not demanding the ionic equation, a simple equation, then you can very well write it as K2Cr2O7 plus Na2SO3 gives Cr3 plus and SO4 2 minus ion. But since the question is saying write the net ionic equation, we have to write it in the ionic form. Clear? So first step is you have to write the skeletal equation. Now, what do you mean by skeletal equation? You have studied in smaller classes, isn't it? Skeletal equation means which is not a balanced equation, only the skeleton in terms of ions. So, the first step is write the skeletal equation. How will you write? Potassium dichromate, the skeletal equation with me, Cr2O7. Now, what is the ion? Because ionic equation, since the potassium we are deleting the potassium because we are removing the potassium. How many potassium is there? 2 plus. K is, potassium is plus, valency plus 1. So, how many potassium? 2. So, 2 plus are removing. So, for that it will be 2 minus. Correct. Why 2 minus? Because the sum, algebraic sum must be 0. So, if you remove the K2, 2K, you have to put 2 minus. Correct. Then, plus Na2SO3, you have to put SO3 and 2Na. Na is plus 1 valency. So, 2Na. So, it is again minus 2. Correct. And both are in aqueous because it is in acidic medium solution. Will give you, this you have given chromium ion plus sulfate ion. Okay. This is the skeletal equation. So, first you have to write the skeletal equation. So, is it clear the first step? Okay. Now, you are going into the second step. Now, what is the second step? You have to assign the oxidation number or which atom is getting oxidized and which atom is getting reduced by assigning the oxidation number for each element. Then only we will know which is oxidizing and which is reducing, isn't it? So, you have to ascertain the oxidation number for all elements like Cr2 plus O7, then SO3, Cr, like this. So, first we will see the chromium. Correct. What is the oxidation number of chromium here? And you know how to find out this chromium. How you will find out? If the chromium is X, you can say, I will write it here, 2X, then oxygen 7 and that is minus 2. So, 2X minus 14 equals minus 2. Why I put minus 2? The charge. Why I put charge? Because as the rule goes, if it is a neutral molecule, we can equate it as 0. But this is a charged particle. So, you have to equate it as the charge. So, you know 2x is equal to 12 or x is equal to 6. So, what is the oxidation number? Plus 6. Correct. In the same way, sulfur. Sulfur also, I will write it here. That is x minus, oxygen is minus 2. So, minus 6 is equal to minus 2. So, x is equal to plus 4. So, sulfur is having plus 4 oxidation state. Clear? Now, chromium here it is given simple Cr3 plus and SO4 you have to find out x minus 4 into minus 2 minus 8. So, x minus 8 is equal to SO4. So, it's not 3 minus, it is 2 minus, right? See, here it is 2 minus, right? So, here 2 minus. So, it will be minus 2. So, x is equal to plus 6. So, here the sulfur is plus 6. See? So, you have to identify. So, we have found out the oxidation number of all the elements, right? See, we have to find out the oxidation number of all the elements and now we can say that here the chromium is undergoing an oxidation number change. Correct. Plus 6 to plus 3. Then, so 2 chromium means plus 12. That's charge. Then the sulfur is going from plus 4 to plus 6. So, increasing. So, chromium it is decreasing plus 6 to plus 3. So, for chromium it is a reduction, oxidation number reduction, decreasing. But for sulfur it is increasing, that is oxidation. So, chromium is getting reduced and sulfur is getting oxidized in this equation. Is it clear now? Okay. Now, we will move on to the second step. Correct. Second step, Now first you have to in the second step you have assigned the oxidation number, correct? So I will write it once again because this is somewhat confused for you. So I will write in the second step Cr2O7 2 minus plus SO3 2 minus will give you Cr3 plus SO4 2 minus, correct? And what is the oxidation number? That is plus 6, then plus 4, isn't it? Plus 4, then Cr3 plus, here the sulfur is how much? Plus 6, correct? So this is the second step. You have assigned the oxidation number for all the elements. Now you should calculate the increase in or the decrease in the oxidation number, correct? You have to see oxidation number increasing and decreasing. See, first we will see chromium. What is chromium? Chromium, the oxidation number is decreasing, that is plus 6 to plus 3. So it is reduction, isn't it? It is reduction. What about sulfur? Sulfur, you see, plus 4 to plus 6. So oxidation number is increasing, so it is oxidation. Clear? Okay. Now what you have to do is, then the third step. Okay. Now what is the third step? You have to balance, okay, you have to balance the chromium and sulfur. Whichever is going on oxidation and reduction, you have to balance that too. First you have to balance, since chromium is reducing and sulfur is oxidizing, first you have to balance these two in the given equation. So how will you balance? This chromium, here it is 2 chromium, so you can put 2 chromium here, correct? I can put 2 chromium here. Okay, so I can put 2 chromium here, but sulfur is 1 and here sulfur is 1. So so nothing can be changed. So I can write, if balance, Cr2O7, can you see, 2 minus plus SO3 2 minus will give you 2 Cr3 plus SO4 2 minus. See? Correct. Cr3 plus. Now you see the oxidation increase and decreasing the oxidation number, you have seen, or you have balanced the chromium and the sulfur. Now what is the next step? The next step is, see, how much is getting oxidized and reduced. See, so this is plus 6, this is plus 4, this is 3 plus, and this is plus 6. See? Okay. Now the next step is you have to balance the charges. See, you have to balance the charges in this. Okay. Now how many so in order to balance it, now no, before that you have to go for one more step. See, now we know how much is increasing and how much is decreasing. Okay, now how much the oxidation number is increasing and how much the oxidation number is decreasing, that you will see. Now see, for chromium, listen, for chromium it is, how much is the oxidation number, how much is increasing? 6 into 2, that is, this here it is charge, no, plus 12, and here it is plus 6. Now what is the difference? You know the difference is plus 6, correct? The difference is plus 6, correct? So this is the, and what about the sulfur? Sulfur is, you know, it is simple. So plus 4 to plus 6. So it is plus 2, correct? Got it? Don't confuse it. First you have to balance this chromium and sulfur. Okay, first you have to balance this chromium and sulfur. Then you have to make the charges. You have to make the charges, whatever is the increase and decrease, you have to make them same by cross multiplying the charges. Increase and decreasing in the oxidation number, you have to cross multiply. So here the difference is plus 12, that is 2 into 6, this is plus 12, and here it is only 6. So what is the difference? 12 and 6, 12 minus 6 is 6. Okay. Now here it is plus 4 and plus 6, so it is plus 2. The difference is plus 2. The difference, correct. This difference is plus 6 and difference is plus 2. Oxidation number, correct. So then you can divide it by 2, then it will give you 3. You divide it by 2, you will give 1. So you can divide by a common factor 2. So you will get 3 and 1. Correct. Now what you have to do is, see, for chromium to chromium, it is 3. The difference. Sulfur to sulfur, it is 1. So what you have to do? You have to multiply 1, cross multiply. Here one thing is there. You have to cross multiply it so that to become equal. Correct. So you have to multiply this number, the sulfur and sulfur number to chromium and chromium, and the chromium difference number to this sulfur and sulfur, that is sulfite and sulfate. So what will be it? It will be sulfur means 1. So it remains as Cr2O7 2 minus, plus for sulfate you add that difference in the chromium. So 3SO3 2 minus, okay, gives for chromium it is 1. Correct. So 2Cr3 plus SO4 I have to give 3. So 3SO4 2 minus. Correct. So you have to cross multiply it to make them equal. Correct. To make them equal. Now what you have to do? Now the fifth step is what? You know the reaction is taking place in acidic medium. We have seen in the question, see, this Na2 in an acidic medium. Okay, so as the reaction is taking place in an acidic medium and further the ionic charges are not equal, see, we have to make the ionic charge equal. So that is the next step. So making ionic charges equal. There are different methods for this, right? So I am taking the method in which your textbook is given. There are also another easier method that I will teach you later. Okay, so this is according to textbook. So making ionic charges equal, we have already said in the rule, like you have to add H plus or OH minus according to the medium. So here it is acidic medium. So you will go for it. How? See, ionic charges means here it is 2. Okay. So here it is 2. Correct. Here it is 2 plus minus 2. Minus 2 plus 3 into minus 2 is minus 6. So minus 2 plus minus 6. That is the reactant side, ionic charge. Now what is here? Here it is plus 6 and minus 6. Correct. So plus 6 and minus 6 will be 0. And minus 6 and minus 2 is minus 8. So the charges are not equal. See, here on the LHS the charges is 8 and RHS it is 0. Now how will you make it equal? Here it is minus 8, right? The charge. So since we have set as an acidic medium, what you have to do? You have to put H plus. How many H plus? 8 H plus. You have to put 8 H plus. That means plus 8. Correct. Plus 1 means 1 into 8 is plus 8. So plus 8 in the reactant side, so that the minus 8 and plus 8 will cancel, and in the both case 0 is there. Clear? Okay. Now my sixth is, how will I write? I will write Cr2O7 2 minus plus 3SO3 2 minus plus 8H plus. You know why I put 8H plus? Because in order to equalize the charge. Because here there is minus 8, here there is 0. So in order to have, since it is acidic medium, I have to add H plus ion. So here I will put H plus ion so that this 8 minus and plus 8 will cancel out and form 0. The RHS is anyway 0. Okay. So that is equal to, that is 2Cr3 plus 3SO4 2 minus. Is it clear? Okay. Now, then what you have said in the rule, you have to count the number of hydrogen atom. Okay. How many hydrogen atom is there? 8 hydrogen atoms are there. 8. Correct. So that 8 hydrogen atom, you have to put it in water, in the form of water. So how many water molecules I will put? 4 water molecules I will put. And the 4 water molecules I will put on the right hand side, because here it is 8. So in order to counter the hydrogen ion, I will put the H in the RHS. So what is the equation then? Cr2O7 2 minus plus 3SO3 2 minus plus 8H plus will give you 2Cr3 plus 3SO4 2 minus plus 4H2O. Clear? 4H2O. Correct. So now you will get what? You will get balance because there is 8. Correct. 8. Now if you see oxygen atom balanced, oxygen atom, how much is the oxygen atom? Oxygen atom here it is 7 plus 3 into 3 9. Then here oxygen atom is how much? Correct. Oxygen atom is 12. Is 4 3s are 12. 12 plus 4 16. So 7 plus 9 is 16 oxygen. Correct. And 12 plus 4 is 16 oxygen. So the oxygen is also balanced. So this is our final balanced redox reaction. Hope you understood how to balance the redox reaction. Okay, so is it clear? Okay, so I will give you one homework. You have to write that homework. Okay, the homework is, please write. The homework is, okay, the homework is permanganate ions. Okay, now the homework is permanganate ion. What is permanganate ion? MnO4 minus. Permanganate ion react with bromide ion, that is Br minus ion, in basic medium. You have given a hint like basic medium. So basic medium means in the last case we have studied acidic medium, so we put H plus. Here you have to put the OH minus. Okay, so to give manganese dioxide, that is MnO2, and bromate ion, that is BrO3 minus ion. Okay, so you have to write the balanced, correct? You have to write the balanced ionic equation. For this, if there is any doubt, you can call me. Okay. After that, I will give you one more homework. If you want a homework, I will give you a simple one. That is, okay, I will do it for you afterwards. Okay, that is a little bit complicated. So please do this. Then be confident enough. Then we will do another complicated thing. Okay. So this is the oxidation number method. So hope you are clear with the oxidation number method. Correct? Okay. Now we will see the next method, that is half reaction method. That is very simple. The second type is called as the half reaction method. Okay. Half reaction method means, I have told you earlier, in a redox reaction, there are two half reactions, isn't it? There are two half reactions. That is, one is an oxidation reaction and other is a reduction reaction. And you know, if only an oxidation and reduction takes place simultaneously, you have to call that reaction to be an redox reaction. Clear? Okay. Now we will see one example of this, how to balance this balance this redox reaction in half reaction method. So hope you are clear with the oxidation number method. Okay. Now for an example, if we want to balance the equation showing the oxidation of Fe2 plus ion, okay, Fe2 plus ion to Fe3 plus by dichromate ion. Dichromate ion means Cr2O7 2 minus. Correct. that is Fe2 plus to Fe3 plus. Correct? In acidic medium, you have given a hint like this reaction is taking place in acidic medium. Again, the reaction or the question states that this Cr2O7 2 minus is reduced to Cr3 plus ions. So already in the equation, it is given that the Fe2 plus, Fe2 plus is getting oxidized to Fe3 plus and the Cr2O7 2 minus is reduced to Cr3 plus. Okay. Now, first you have to see, normally what happens is, you will be given a question not in this form, but in a statement or in a word form, which we have seen in the earlier numerical. A word form like balance the equation showing the oxidation of so and so to so and so with so and so to so and so. So you will be given a word numerical. But here I have given you a ionic equation straight away. If a word numerical is given, you have to convert that into this ionic equation, which we have done in the last numerical. Correct? Okay. So now in this numerical, I am straight away giving you the ionic equation, and you are giving the hint as acidic medium. So this is the skeletal equation. What we have write in the last numerical, this is the skeletal equation. Okay, skeletal equation. Skeletal equation means unbalanced equation, right? Unbalanced equation. Correct. Now you have to. Now the second step is, this is the first step, skeletal step. Then the second step is what it is? They separate this equation into half reaction. That is our main thing. Okay. Now what you will do in the second step, you have to separate this equation, the skeletal equation, okay, the skeletal equation into what? Into the half reactions. We know there are two types of half reaction, oxidation as well as reduction. Clear? So from this ionic equation itself, you know which is oxidized, that is Fe2 plus giving Fe3 plus. Correct? You know that. So this we call it as oxidation half. What is it? Oxidation half. Okay. Now what will be the reduction half? What will be the reduction half? Cr2O7 2 minus will give you Cr3 plus. So this you say it as the reduction half. Okay. This you have to say as reduction. But in the last time or the last method, you have to find out which is getting oxidized and which is getting reduced, and then you balance that. Other than that, balance the charges, putting hydrogen if it is in the basic acidic medium or OH minus in the basic medium. The count for the H plus ion in the acidic medium with water. Then you balance the oxygen. If everything is okay, then the equation is balanced, isn't it? So here what we will see is, we have written what? Oxidation half and the reduction half. Clear? Okay. Now, the third step is, balance the, so you have written the separate oxidation half and the reduction half. Correct? If you want to know Fe3 plus, the oxidation is plus 2, this is plus 3. Correct. Now what about the Cr2 plus? Yeah. Here we will see how the reduction happens. In the last we have seen this is Cr plus 3 and sorry, this is plus 6 and plus 3. So oxidation number is decreasing. So it is reduction. Correct. Okay. Now what you have to do is balance the atoms other than oxygen. You have to balance the atoms other than oxygen balance the other atoms other than oxygen and hydrogen. So you have to balance the atoms other than oxygen and hydrogen in each half reaction individually. Okay. So here since already the reaction is balanced with respect to iron, Fe is 1, Fe is 1. Correct. Now here you are not going into oxygen, you are going only the chromium. The rule says that other than oxygen and hydrogen, you balance it. Correct. So in this second case, there are 2 chromium atoms. So you have to multiply this into 2. So the second reaction will be, the new reaction will be Cr2O7 2 minus will give you 2 Cr3 plus. So the new reduction half cell. Correct. The new reduction half reaction. Clear? Okay. Now what happens? Since they are telling it, this reaction happens in the acidic medium, what happens? You have to add water in order to balance oxygen atom and H plus to balance the hydrogen atom. See what it is there? For oxygen atom, see, for oxygen atom to balance, see, I will write it in another way. If you have to balance, correct, if you have to balance oxygen atom, add that much water molecule, and if you want to balance hydrogen atom, add H plus ions wherever necessary. This is the funda. Okay, so by taking that funda or the concept, here the first equation is simple, Fe2 plus Fe3 plus, don't worry that. So the worrying thing is Cr2, that also we have balanced the Cr, but 7O. So what you have to see, Cr2O7 2 minus will give you 2 Cr3 plus plus 7 H2O. See, 7 oxygen, correct? 7 oxygen. So now the oxygen is balanced. Now what about the hydrogen? Hydrogen, there is 14 hydrogen here, correct? So in order to balance this hydrogen atom, you have to add what? H plus. So here in the LHS, you have to write left hand side Cr2O7 2 minus plus 14 H plus will give you 2 Cr3 plus plus 7 H2O. So now everything is balanced. Clear? Is it clear? Okay. Now in this method, in this half reaction method, the very important step, so this is the 4th step, correct? This is the 4th step. Now the very important method, that is the 5th step, is you have to balance the electrons. Okay, so why you want to balance the electrons? You have to equalize the charge. Now the next step is you want to equalize the charge. Correct, equalize the charge. That is very important step. You see, Fe2 plus will give you Fe3 plus. That is the oxidation half. So the charges are not equal. This is F2 plus, this is 3 plus. So in order to make it 2 plus, what I will do? I will, here one electron is added, 1 minus 1. So 3 plus 3 minus 1 plus 2. So this reaction, it is, the charge is balanced. Clear? Is it clear? Okay, simple. Fe2 plus is there, Fe3 plus. The charges are not balanced. So what happens? You have to make it balanced. So I add 1 minus charge to it, so that this will, as a whole, the charge will be plus 2. So the charges plus 2 and plus 2 is equal. Now in the reduction half reaction, we will see the charges on the LHS and the charges on the RHS. See how it goes. What is the charge? Charges, this is 14 plus and 2 minus, isn't it? So 14 plus 14 and minus 2. So then here it is plus 6, correct? Plus 6. So here it is plus 12, here it is plus 6. In this reaction, Cr2O7 2 minus plus 14 H plus will give you 2 Cr3 plus plus 7 H2O. In the left hand side, the charge is plus 12, and in the right hand side, the charge is plus 6. Correct. Now here it is here how many is more here? Here if you cut down, here it is 6 plus charges is more. So in order to make equal charge, so here there is 6 charge more, 6 plus charge is more. You have to equalize this by adding 6 electrons. That means negative charge. So equalizing the charge by adding electrons. That is also important. So now my new equation will become Cr2O7 2 minus plus 14H plus 6 electron. You got it? Why I wrote 6 electron? Because there is 6 positive charge. By equalizing this plus 12 and plus 6, here plus 6 is there more. So in order to equalize that, I add 6 electrons. That means minus charge. So 6 plus and 6 minus will give away 0. So the equation is balanced. So 2Cr3 plus 7H2. Clear? Okay. Now one more thing you have to see. See, now if I write this equation as the first equation and if I write the second as this equation, you see, is the number of electrons same in these two equations? This is the oxidation equation and this is the reduction equation. See? Now, is the number of electrons is same? No. Here there is only 1 electron. Here there is 6 electrons. Normally, in a reaction, when we add both this oxidation and reduction or whatever reaction we add in the redox, the number of electron should cancel out. That is a rule. So, in order to make the number of electrons equal or to equalize the number of electrons in both the half reactions, what you have to do? Here it is 6 and here it is 1. You have to cross multiply. You have to multiply this oxidation equation with 6 and the reduction equation with 1 because this is 1 electron. So here cross multiplying, what you will get? You will get, I will write it, you will get what? You will get, so 6 electrons is there. So that remains same because you have to multiply it with 1. So Cr2O7 2 minus plus 14H plus 6 electron gives 2Cr3 plus 7H2O. Correct? Now second, you have to put 6 electrons you have to get. So 6 Fe2 plus gives 6 Fe3 plus 6 electron. Clear? So now you got the electrons also correct. So this is the first equation and this is the second equation. Clear? This is the first equation and this is the second equation. Now what you have to do? Now you have to add the two equations and cancel the electrons on each side, which will give you the net ionic equation. What is it? To cancel out the electrons and add. So 1 plus 2. So 6 electron and the 6 electron cancel. So the equation will become 6 Fe2 plus Cr2O7 2 minus. Okay, you are not seeing. So 6 you have to, what you have to do? You have to add this 1 plus 2 and then you will get 6 Fe2 plus Cr2O7 2 minus plus 14H plus will give you 6 Fe3 plus 2 Cr3 plus 7H2. See? Okay. So please recheck the number of atoms are all same. So this is our balanced redox reaction. Clear? This is our balanced redox reaction. So hope you understood. Write and study once again. Okay. Till you are confident in doing it in your own. Okay. So any problem you can ask me. Correct? Okay. Now I will give you a homework for this in order to do for the oxidation reduction reaction. Okay. Now the homework is I will give you straight away the skeletal equation like MnO4 minus, okay, MnO4 minus plus iodide ion will give you MnO2 plus I2. Okay, that is permanganate ion, and they have specified it in a basic medium. So try this out. If any problem, just tell me. So this they have given in a basic solution. Okay, the I minus, the permanganate MnO4 minus ion oxidizes the I minus to I2. So I minus and I2, the oxidation happens. This is reduction happens. So you have to write the oxidation first, the oxidation reaction. Next, that's the reduction reaction. Then you have to balance it, the oxygen atom, then hydrogen atom, then equalize the charge by adding the electron, and finally count all the atoms are equal. Then you will get the final result, that is balancing the chemical equation. Okay, so hope you understood this two methods, that is oxidation reduction method as well as the oxidation number method as well as the half reaction method. So this is all with this chapter, redox reaction. The next is the application, which is deleted from this chapter for this year 2021 exam. So it is not necessary to go through it, but if somebody wants to go through it, just go through and read the textbook. That is the application. We will do this redox reactions in titrations, in practicals. Okay, so that this redox reaction is mainly the basis for this titration, what you will do in the lab. Okay, that section is deleted. It's only a small portion. It's only just one page it is deleted. So there comes the end of this chapter. So hope you are clear with it. Any doubt, please give me a call. So in the next session, we will be starting with the next chapter. That is, what is that chapter? That is a very simple chapter, which is hydrogen. Okay, so till then, thank you.